We'll be taking up a couple of long questions based on the trigonometric identities. The first three we remember is sine squared theta plus cos squared theta is 1, and then the one with cosec and the sec. I don't do I have to recall? No, I think you know, or should I? Let me. So cos squared theta is equal to 1 plus cot squared theta. That's the third one, and one more, if I recall correctly, will be sec squared theta is 1 plus tan squared theta. Okay, these three we had discussed in one of the previous sessions. Herein I will be taking a couple of long questions based on these trigonometric identities. The first one I had taken, the first one, or not I, even if I had taken, or you get through, is a direct question when you start solving it from the left hand side and reach the right hand side, and that gives you the proof. But herein I am taking up a question where you have to work on both sides to, prove your question given. So let me just write it down. These will be long questions when this will be taking up this session. Not this one much, but though the next one will also be 1 by sine A. This is also a proof. We start with LHS first and then take up the RHS. You can read the question, which says 1 by cosec A cot A minus 1 by sine A is equal to 1 by sine A minus 1 by cosec A plus cot A. Let me start with LHS. Now I'm not writing it again, I'll just start solving it from here only. I will be multiplying a cosec theta plus cos theta in the numerator denominator in this first term. So I'm getting 1. Because I have a value which says cosec A minus cot A, and I want to remove this part in the denominator, so I'm multiplying cosec A plus cot A by cosec A minus cot A. So I have to obviously multiply the same thing below in the denominator, cosec A plus cot A. Let me keep this, the first term, in the bracket as well. The rest of 1 by sine A will remain as it is. Alright, now the numerator is cosec A plus cot A will remain as it is, and in the denominator, wait, just let me write it down first. Now the one below will give you under A plus B, A minus B, so will give you cosec square A minus cot square A. Cosec square A minus cot square A. Now what about 1 by sine A? 1 by sine A should be represented now as cosec, just to give the similarity all the terms. So cosec square A minus cot square A is 1. So we are getting cosec A plus cot A minus cosec A again. Thereby it is erasing these two, and I'm getting a cot A for the LHS. Now I need to continue with the right hand side. I'll make a bar line here so that we can differentiate between where I'm taking the right hand side. This is our RHS. I had 1 by sine A. The same thing I'll do it here to remove this cosec A plus cot A by multiplying cosec A minus cot A in the numerator and the denominator. So this is converted to cosec A, and here I will similarly be getting 1 into cosec A minus cot A. I told you how and why in the previous part as well. So cosec A plus cot A, this is multiplied to cosec A minus cot A. So that's leaving me with cosec A as it is. In the numerator it is again cosec A minus cot A by, this is again cosec square A minus cot square A. So cosec A is minus, again will leave us with cos square A minus cot square A. Now as because it has a minus and this is cosec A minus cot A, and I remove the bracket, I remove it, will be plus cot A. This getting cancelled, I'm left with the cot A. So thereby LHS is equal to RHS. That means what? Every time it's not necessary that you get the answer, you reach your right hand side by starting with LHS. Sometimes you might need to take this kind of process wherein you have to work on both the sides. Okay. Yeah, I take up another question by a different type. Okay. Now it says if I use red, that helps me better. If cos alpha by cos beta is equal to m and cos alpha by sin beta is equal to n. So m and n are represented by these expressions. We have to show that though I first thought of taking another long one, but I thought otherwise again, so I put this one which is a bit different with expressions. Yeah, I'll surely be taking a few long and hot questions. Okay, we have to prove m square plus n square with cos square beta is equal to n square. Okay, let me take up LHS. LHS says it is m square plus n square. Okay, m square plus n square, and there is a cos square beta as well. M was represented by cos alpha by cos beta, but as because it is a square, it will be cos square alpha by cos square beta plus n is cos alpha by sin beta, the same thing, so I'll just write it in square by sin square beta. And this is also multiplied by this term which is cos square beta. We proceed with taking up LCM here. So my LCM gets cos square beta and sin square beta. So I'm left with a cos square alpha and a sin square beta. So cos square alpha with a sin square beta plus cos square alpha with cos square beta. And you also had this cos square beta left. Now if you see, I can take a cos square alpha common. So cos square alpha, if taken common, will be left with a sin square beta plus cos square beta by cos square beta sin square beta, cos square beta with sin square beta. Let me continue it on this side with a dotted line. Let me separate it. Oh, I left this writing as well. I also have a cos square beta. Now am I getting cancelled with something? This and this getting cancelled. So what am I left with? I'm left with a cos square alpha by sin square beta. This is sin square beta plus cos square beta is 1. So once I write it, it will be cos square alpha by sin square beta. Now cos alpha by sin beta is represented by n. So we can write it as cos alpha by sin beta is square. So this is n square. Isn't that pretty simple for you? The next one, I give you a kind of a question noted and would like you to solve it by yourself. So note down the question. It says if cosec, how do I represent theta? Let me just write it. Cosec theta minus sin theta is equal to 1 and sec theta minus cos theta is equal to m. Oh, this is not given to be 1. I can know how can they give it to be 1? Cosec theta minus cos theta should also be represented by some variables. It's L. Cosec theta sec theta minus cos theta is given by m. You have to prove the following. It says L square m square multiplied to L square plus m square plus 3. They all should be giving you 1. So what I can just help you to say, to help you that just continue with the left hand side as it is given. Just have to replace the variables with the expressions given, though it might go a little long, but keep your patience, continue, and you'll see that you are reaching this 1. Hope you get that right. Thank you.